Welcome to the Lake County General Health District's Drip Demonstration Project. This drip distribution demonstration project was made possible by a grant from the Ohio Lake Erie Commission and the Lake Erie Protection Fund. The monies for the Lake Erie Protection Fund are supported by the citizens of Ohio through their purchase of the Lake Erie license plate. The purpose of this video is to provide a brief overview of the installation, inspection, and service required for the proper construction and operation of a drip distribution sewage treatment system. Drip distribution is a fluid handling system that utilizes timed microdosing for the dispersal of sewage effluent in a soil absorption sewage treatment system. The advantages of drip distribution are the ability to overcome soil limitations such as a shallow bedrock, seasonal perched water tables, and slowly permeable soils. The zones of a drip distribution system provide the flexibility to utilize the various contours existing on difficult topography that would otherwise hinder the use of traditional soil absorption trenches. This video will demonstrate the installation of a drip distribution sewage treatment system where tubing will be installed in 3 applications: placed on a sand mound, installed on a basal area at grade, and below grade using a vibratory plow. A proper soil and site evaluation is necessary before the installation of any sewage treatment system. Suitable topography considers the landscape features, prior uses of the property, existing structures where applicable, and surface water flow. A proper soil evaluation is conducted preferably by a certified soil scientist and must always utilize the USDA nomenclature for the description of the soil characteristics and limitations. These characteristics and limitations are used to establish the system design parameters. Design plans must be prepared utilizing the site and soil evaluation information and must include construction specifications. Prepare the site according to the design plan. Flag or rope off areas for basal preparation of the site as well as to protect the site from potential damage. A soil ribbon test demonstrates whether the soil is sufficiently dry and crumbles, which is necessary to prevent smearing and compaction during the installation of the basal area. Prepare the basal area by removing brush and small trees or removing grass from the ground surface. Flush cut brush and trees, then lightly scarify the basal area of the mound and at grade to a depth of approximately 6 inches to establish a good soil interface. Place sand meeting the plan specifications on the basal area at a depth according to the design plan. Sand should be placed from the uphill side of the mound to prevent compaction of the basal area from unnecessary traffic. Place the drip tubing at design length on top of the mound. Tubing spacing should be maintained in accordance with the plans. The drip tubing contains pressure compensating emitters spaced every 2 feet to evenly control the flow of sewage effluent at each orifice. Place the drip tubing at grade and carefully maintain tubing spacing. Install plowed-in tubing using a vibratory cable plow while carefully maintaining tubing spacing. Use duct tape to seal the ends of the tubing to prevent soil and stones from entering into the tubing during construction. Remove the duct tape from the ends of the tubing and use a pipe cutter to establish a clean cut with no ragged edges. Connect the ends of each tubing run with the black flexible PVC. Use the proper connectors, Teflon tape, and fittings. PVC primer and glue must be used to ensure a proper bond. Excavate the header trench at a depth to ensure frost protection. In this project, the header trench has been kept shallow for easy viewing for future training purposes. Construct the PVC manifolds in accordance with the plans. Each zone has a manifold system. The supply manifold functions to supply effluent to the tubing, and the return manifold functions to return effluent used during the forward flush that scours the tubing to keep it clear of biological growth. Return effluent flow is piped back to the treatment tanks. Color coding with tape or spray paint assists in identifying piping for proper connections. Install an air release valve and check valve on each zone. Air release valves and check valves should be placed in the highest point in each zone. An air release valve is installed on the tubing side and the check valve is installed on the return lines prior to the common return. This top feed manifold configuration, where individual supply and return lines ensure even distribution, could be considered for hillside installations where slopes exceed 5%. Connect the drip tubing to the manifold utilizing the black flexible PVC. Flexible black PVC must extend a minimum of 12 inches into the header trench to protect the tubing from crimping. The purpose of the hydraulic unit is to regulate and filter the flow of sewage effluent out to the zones, to return the forward flush effluent to the treatment tanks, and to record the volume of daily wastewater flow. Excavate for the hydraulic unit in accordance with the plan. Set the hydraulic rack on a gravel bed in the excavation. The excavation must have a gravity drain for condensate drainage to a proper outlet. The hydraulic unit of an American Manufacturing drip distribution system must be placed within 10 feet vertical and 30 feet horizontal of the pump to ensure proper head pressures. Connect the return and supply lines to the hydraulic unit as per plan. Quick disconnect unions should be installed in the hydraulic unit for ease of future service, especially if removal of the hydraulic rack is needed. Install pretreatment tankage and dosing tank as per plan. For this project, there will only be a dosing tank in the system for demonstration purposes. Excavate the hole and prepare the bedding according to the tank manufacturer. All tanks must be watertight. Install the pump according to the manufacturer's specifications. Next, install the pump float tree. The interceptor drain can be installed at any point during installation. The purpose of an interceptor drain is to collect and divert surface water sheet flow and seasonal groundwater flow away from the soil absorption area of the sewage treatment system. Electrical service for American Manufacturing drip distribution systems requires 3 dedicated 115-volt circuits, 1 with 20 amps single phase, and 2 with 15 amps single phase. A licensed electrician will connect the hydraulic unit to the control panel. All electrical work must be in accordance with the National Electrical Code. Be sure to properly connect the heater pad inside the hydraulic unit to prevent freezing during inclement weather. Connect the flow tree and pump wires to a NEMA 4X junction box. The inspection process by the local health department staff begins after installation and before backfilling of the system. The dosing station has been filled with water to enable the startup inspection process. Remove the air release valves to flush out any debris that may have entered into the system during the construction. Then, permanently install the air release valves. Place the pump into the hand position in the control panel. There should be no movement of the flow meter. Movement of the flow meter could indicate possible leaks in the system that would require correction. Move the filter backwash switch to the hand position. The filter should flush for a minimum of 15 seconds. Then place the switch to the auto position. Repeat this process for the other filters. At this time, the system is tested for leaks in proper flow and flush rates. First, turn the pump on and to the hand position and zone 1 to the hand position, which sends water to the zone. Turn the zone return valve to the hand position to purge any remaining air from the tubing. Close the zone return. Once the flow meter has been stabilized, check the flow rate and compare it to the design specification. Place the zone return switch back to the hand position and take a 1-minute flush rate reading. Calculate the minimum flushing flow rate needed and compare to the actual flow rate. The field flushing rate should exceed the calculated flushing rate. If the field flushing rate does not exceed this rate, this can indicate potential issues requiring troubleshooting. Repeat this procedure for each additional zone. During the startup process, the system is pressurized. All connections, fittings, and unions must be inspected for leaks. Check the alarm function of the flow tree to determine that all floats are properly operating by checking the output lights in the control panel. Set the pump runtime dial using the handheld computer and a screwdriver to set dosing duration as per the plan. The system can be backfilled after the inspection is completed. The area around the septic tanks, around the dosing tanks, and the header trench can all be backfilled. Geotech fabric is placed on top of the tubing on the mound. The solid black flex PVC must be tilted upward to drain sewage back into the tubing for distribution of sewage through the emitters. The areas are then covered with topsoil. Once the sewage treatment system is installed and operational, routine maintenance is required. A qualified service provider should perform an evaluation and the necessary service in accordance with the manufacturer's recommendations. All sewage treatment systems require management of the solids that accumulate in the tank. A sludge judge is an effective tool to measure the solids or sludge level in the tanks. Next, check for any leaks on the hydraulic rack while it's pressurized. The disc filters are inside the hydraulic unit of the drip distribution system. Remove the disc filters. Clean the disc filters by rinsing them in water. Replace the filters and cover. Turn on the pump and check the dosing flow rate and the flushing flow rate following the same procedure as used during the system startup process. Record the flow readings and meter reading on the service inspection form. Compare the operational flow rates to the startup numbers obtained at completion of the system installation. Make any adjustments as needed. Ensure that the installation is in good condition. Check for animals moving into the hydraulic unit and for any frayed wires. The next step in service involves evaluation of the soil absorption components. Perform a visual inspection of the drip zones. Look for animal intrusion, any damage to the area, or any other signs of stress. With proper installation and regular inspections and maintenance, a drip distribution sewage treatment system can offer years of reliable service. Special thanks are extended to the following individuals, agencies, and companies whose generous contributions of time, labor, and materials also made this project possible.